Hello, my dear students. Today we will discuss about thermal stresses and thermal strain, or temperature stresses or temperature strain. Okay, what is this thermal stresses or strains? Say, whenever there is some increase or decrease in the temperature of a body, it causes the body to expand or contract, right? If the body is allowed to expand or contract freely with the rise or fall of the temperature, no stresses are induced in the body. You just imagine when the body is allowed to expand or contract freely with the rise or fall of the temperature, no stresses are induced in the body. But if the deformation of the body is prevented, means if the expansion or contraction is prevented, some stresses are induced in the body. Such stresses are known as thermal stresses or temperature stresses. You understood, no? When it is allowed to expand freely or contract freely, there is with the rise or fall of the temperature, there is no stresses are induced in the body. But if the deformation of the body is prevented, then stresses induced in the body. Such stresses are known as thermal stresses or temperature stresses, and the corresponding strain are called as thermal strain or temperature strain. So this is mainly about thermal stresses and strain. Okay, then how you can find the thermal stresses and strain in the case of a simple bar. We will see that. First, what you have to do, you have to calculate the amount of deformation due to change of temperature with the assumption that the body or bar is free to expand or contract. Okay, first you have to calculate the deformation due to the temperature with the assumption that the body is free to expand or contract. Next, what you have to do, calculate the load or a force required to bring the deformed bar to the original length. Okay, then calculate the stress and strain in the bar caused by this load. Then the thermal stresses or strains may also be found out first by finding out amount of deformation due to change in the temperature, and then by finding out the thermal strain due to the deformation. Any method you can use. The last one is the thermal stresses may now be found out from the thermal strain as usual. Okay, see how you can do, like let us consider a body subjected to an increase in the temperature. Okay, this is one body of length L. Okay, when there is a increase in the temperature, what happened, there will be increase in the length. You can see here, this is the original length, but because of the increase in temperature, there is a rise in the temperature, there will be increase in this length. Okay, you just one thing you remember, when there is increase in the temperature, the body elongates. When there is a fall in the temperature, then body shortens. Okay, so now here it is increase in the temperature. So here you can see this extension. This extension is given by alpha into T into L. Okay, so here L is the original length of the body and T is the rise or fall of the temperature, but here in the case it is the rise, and alpha is coefficient of thermal expansion. So how you can write increase in the length due to increase of temperature, delta L. How you used to write delta L is equal to PL divided by AE. But here, because of the temperature, you have to calculate delta L is equal to L into alpha into T. Okay, here L is the original length of the body and alpha is thermal expansion, coefficient of thermal expansion, and T is rise or fall of temperature. Okay, see this is when the body is free to allow to expand. Okay, suppose if the ends of the bar are fixed to rigid supports, okay, so that its expansion is prevented. Okay, when means if because of the rise in the temperature or fall in the temperature, the body expands or contracts. But if the body is fixed to some rigid support, so expansion will be prevented. Then what happened? The strain induced in the body, obviously there will be deformation, because when both the ends are fixed, okay, to some supports, then but there is increase in the temperature of on this temperature. So what happens actually? Either body has to expand or it has to contract, but it is prevented, then obviously the strain is induced. So that strain, how you can calculate? You know, strain is equal to change in the length divided by original length. Now what is change in the length? It is L into alpha into T. I have shown that because previously I have derived for that. Delta L is equal to L into alpha into T. Substitute that divided by L. So here L get cancelled. So remaining is alpha into T. So strain is equal to alpha into T. Okay. So stress, we know what is stress. Stress is equal to strain into Young's modulus, because Young's modulus is equal to stress into strain. So stress is equal to strain into Young's modulus. What is strain? Strain is equal to, now derived, that is alpha into T. Substitute alpha into T into E. Okay, so stress is equal to, is given by this formula, alpha into T into E. Okay, where alpha is coefficient of linear expansion and T is equal to rise in temperature. Okay, now you know what is deformation. Deformation, delta L is given by L into alpha into T, and stress is given by alpha into T into E, and strain is given by alpha into T, right? If the supports yield by an amount equal to delta, then the actual expansion that has taken place is given by this. Suppose there is some amount of deformation or deformation, either expansion or contraction, then how you have to use the formula? Delta L is equal to, actually delta L is equal to only L into alpha into T. But if the supposed yield by an amount equal to delta, if there is some decrease in the length, okay, amount of yield, okay, then you have to use this formula. Delta L is equal to L into alpha into T minus delta. This delta is the yield. Okay, then what happens? How you can calculate strain? Strain is equal to change in the length divided by original length. What is change in the length? Now change in the length is L into alpha into T minus delta, okay, divided by L. Okay, simplify this. What happens? Take first this L into alpha into T divided by L. So L get cancelled, alpha T. Then second part here, delta divided by L. Okay, simplify this. You get alpha T into minus delta divided by L. So this is strain. How you can calculate stress? Stress is equal to Young's modulus into strain. Okay, what is strain now? Strain is alpha T minus delta divided by L into Young's modulus is E. Okay, so these things you have to remember. First out, what is deformation? Deformation is given by the formula L into alpha into T. Okay, based on this you have to see how you can find strain. Strain is equal to alpha into T. How you can calculate stress? Stress, you know the relationship between stress, strain and Young's modulus. So stress is equal to strain into Young's modulus. So strain is alpha T into E. Okay, this is stress. Okay, this is strain. Now, if there is an suppose yield by an amount equal to delta, then delta L is L into alpha into T minus delta. Then strain is equal to alpha T minus delta divided by L, and stress is equal to alpha T minus delta divided by L into E. So you remember all these formulas, then you can easily find out the deformation, stress and strain. We'll let us take one example. Okay, before that I'll just give this what is the value of alpha. Okay, now for some particular material, the coefficient of linear expansion is given by this, like this. It is thermal coefficient of linear expansion. Okay, for steel it is 11.5 into 10 raised to minus 6 to 13 into 10 raised to minus 6. For cast iron it is 11 into 10 raised to minus 6 to 12 into 10 raised to minus 6, and for aluminium 23 into 10 raised to minus 6 to 24 into 10 raised to minus 6, and for copper, brass and bronze it is 17 into 10 raised to minus 6 to 18 into 10 raised to minus 6. This you just remember, usually in the problem it will be given. If it is not given, you have to assume. Okay, these are the some standard values of linear expansion. Okay, let us take one example. A aluminium alloy bar fixed at its both ends is heated through 20 K. What is this K? K is Kelvin. Okay, find the stress developed in the bar. Take modulus of elasticity and coefficient of linear expansion for the bar material as 80 GPa and 24 into 10 raised to minus 6 per K respectively. Okay, what is given here? Increase in the temperature, that is given T. T is 20 Kelvin, and what is modulus of elasticity? 80 GPa is equal to 80 into 10 raised to 3 Newton per mm square, and thermal expansion, coefficient of linear expansion, that is 24 into 10 raised to minus 6 per Kelvin. Okay, we know what you have to calculate here. It is asked to find the stress. Only you have to calculate stress. You know the formula. What is the stress? How you can calculate thermal stress developed in the bar? Stress is equal to alpha into T into E. Direct substitution. So what is alpha? Alpha is 24 into 10 raised to minus 6 into T. Temperature is 20 into E. E is 80 into 10 raised to 3. So you get 38.4 Newton per millimeter square or 38.4 MPa. Very simple example. Just you have to use the formula. Okay. Let us say one more example. Two parallel walls 6 meter apart are stayed together by a steel rod 25 mm diameter passing through metal plates and nuts at each end. The nuts are tightened home when the rod is at temperature of 100 degree centigrade. Determine the stress in the rod when the temperature falls down to 60 degree centigrade. Okay. The ends do not yield. There are two cases. First one is ends do not yield, and second case the ends yield by 1 mm. Take E is equal to 200 GPa and alpha is 12 into 10 raised to minus 6 per degree centigrade. Okay, this data given here. You have to see here two questions are asked. First case is the ends do not yield. There is no yield. You have to calculate the stress. Second case is the ends yield by 1 mm. What is that? Delta. Delta is equal to 1 mm. Use that formula and find the stress. Okay, these are the given datas. Length is given, diameter is given, decrease in temperature. Here you see the nuts are tightened first. That time the temperature was 100 degree. But now you have to, the temperature falls down to 60 degree. So what is now T? T is equal to 100 minus 60. That is equal to 40 degree centigrade. That temperature you have to consider. Okay, then use the formula. First case, stress in the rod when the ends do not yield. Direct formula, sigma is equal to alpha into T into E. Substitute, you get 96 Newton per mm square or 96 MPa. Second case is what? Stress in the rod when E ends yield by 1 mm. Okay, so what is the formula? Alpha T minus delta divided by L. Alpha is 12 into 10 raised to minus 6. T is 40. minus delta is 1 mm divided by L. L is 6 into 10 raised to 3 into E. E is 200 into 10 raised to 3. Okay, simplify this. You get 62.6 Newton per mm square or 62.6 MPa. Okay, so this is the way to calculate the stress. Here only stresses are asked. If suppose it is asked to find the strain, then you use the formula. What is strain? Strain is equal to alpha into T. If suppose it is asked to find the deformation, you have to just use deformation is equal to L into alpha into T. Okay, I hope all of you understood. Thank you.